In this video, I'm going to discuss the R of the QR factorization. So the Gram Schmidt algorithm takes two arrows on the left, and it will rotate them until the first arrow is horizontal or in line with the x-axis. So notice how this line was slanted in the beginning, and then after the rotation, it was completely horizontal. It became the new x-axis. So another way of thinking about the problem that R is trying to solve is that it's trying to find the coordinates of our original vectors in a rotated xy space. So for example, if we wanted to find the x value of this first vector in this rotated space, one thing we notice is that because the first vector became the new x-axis, it was put horizontally on the x-axis. It's completely in line with the x-axis. Because of that, we can find its coordinates just by finding its length. We use the Pythagorean theorem and we find its length is radical 2. So let's do the same thing. Let's find the x value of the second vector in this rotated space. So we can find the x value of the second vector in the rotated space by projecting it on to the first vector. Because the first vector is the new x-axis, by projecting the second vector onto the first vector, we'll get its x coordinates. In this case, it's 4 over radical 2. So finally, we do the last thing, which is to get the y value of our second vector, but in this rotated space. So that's kind of like the same thing as finding the length of the perpendicular line connecting the x-axis to our second vector. That'll give us its y value. So if we wanted to find this perpendicular line, we know the way we can get there is we know it's the projection of the second vector onto the first vector. We already know that from the previous step. It's this horizontal part. If we subtract that projection from the second vector, we can get that perpendicular line that we wanted. In this case, it's -1, 1. Finding the length of this perpendicular line is going to give us the height of the second vector in the rotated space. In this case, using Pythagorean theorem, it's radical 2 is the length of that line. And that becomes radical 2 becomes the height of the second vector in the rotated space. And these two columns make up the R matrix, which, as I've shown, is kind of just the rotation of our original vectors. Thank you for watching this video, and I hope you have a great day.